Good afternoon, everyone. My name is Denise, and I'm going to be supporting the webinar today. Today's webinar is on the environment collection, Digimap's land cover plus, and the newly released fertilizer maps from 2015 to 2021. Our presenters will be Dr. Clare Rowland, Earth Observation Scientist, and Emily Upcott, a spatial ecologist at UKCEH.
Okay, so as Denise said, there's two of us talking today. I'm going to be talking about land cover map, and then hand over to Emily, who'll talk about the land cover plus data sets. So hopefully that's gone on to the second slide now. So the talk basically is going to cover what a land cover map is, how we create the land cover map, but then how you can use a land cover map, what the data sets are, because we have a range of data sets. And then I'm going to talk you through how you access the data and the different data formats that we have. So what is a land cover map? A land cover map is a data set, and what it does is it tells you what land cover is where. This is important because land cover is a key environmental variable, and lots of different environmental processes are affected by the kind of land cover. We have 21 land cover classes in the land cover map. And the map here shows the distribution of land cover across the UK. We have a range of woodland classes. We also have lowland classes like arable, improved grassland, neutral grassland. We have upland classes like heather, heather grassland, bog. We have coastal classes as well, and water, as well as urban and suburban. So we cover the full range of land cover classes that you get across the UK. As well as being a land cover, a data set, a land cover map is also a project output. So there's a project that sits behind the land cover map. We're funded by NERC through our national capability funding. And our kind of longer term priorities for land cover map at the moment are to improve the data, expand the land cover map offer, and also increase the accessibility of the data. So I'll come on to that more later when we talk about how you access the data. But one of the things we're very keen to do at the moment is reduce the barriers to access to the land cover data so that it can be used more widely. It's useful to know how we make the land cover data. Because if people see the final data set, it's not clear how we get to that point. And the way we get to the final data set is we take satellite data, we do some preparation on it, then we have a big training data set and we use machine learning and run a classification algorithm to get our final classification. So it's useful for people to understand that that's how we get the data, because when you look at the data, we try to make the data as good as we can, but there are always confusions that we get and sort of errors that creep in. So the data generally is very good, but there will be confusion, and the confusion comes from how we make the data, basically, that you're looking at satellite data and you're looking for kind of areas of woodland that match the areas of woodland in your training data set. If there's something strange going on with the management, it won't look like typical woodland maybe, so maybe you won't classify it correctly. So it's useful to understand where the data set comes from, so that if you see something strange in the data, you can understand why that's occurring. So when you've got land cover data, you can use it for a really broad range of environmental problems. So this slide covers some of the areas where you can use the land cover data. And it's got such a broad range of application because, as I said earlier, land cover is a key environmental variable. So the way that animals move through the landscape varies depending on the land cover. The way that water moves across the landscape varies depending on the land cover. The way that atmospheric pollution affects different parts of the land cover depends again on the landscape structure. So land cover is a really key environmental variable. And so understanding how it's distributed is really important for for kind of understanding a lot of environmental problems. The slide here shows the land cover map. Sorry, I've gone onto the wrong slide there. A couple of land cover map uses. So in one case, people used the land cover map to look at floodplains and to understand the quality of the floodplain. So in this case, they were interested in how how water moved across the landscape and how building up urban areas on the floodplains affected the quality of the floodplain and their ability to function the way that you would want them to function to minimize flooding. The other example also looks at urbanization and how that affects different ecosystem services. So there's a very wide range of questions about the environment that you can answer with land cover data. And when you've got a land cover map, that there are different levels of weight, that there are different levels of interaction, different types of analysis you can do. So I'm not going to cover all of the different types of analysis that you can do with a land cover map, but there's just three kind of, I suppose, core methods here on the slide. So the first one is you can get land cover statistics to characterize an area. So you might have two different study areas in different catchments, and you might want to characterize the land cover in the two catchments. You might have one that's very natural that has a lot of grassland land cover. You might have another that's very urbanized. So you could use the land cover data set to characterize those two different catchments to show how different they were. But you might also want to show how similar they were, depending on what you were doing and what your experiment was. You can also combine land cover data with other data sets. So if you've got information about how much a particular bird species likes different land cover types, you can understand which parts of the landscape they might prefer. If you've got information about the runoff characteristics of different land cover types, you could use that data and the land cover map to produce a map of runoff or some other hydrological parameter. So you can really kind of use the land cover data with other data to get new insights and to produce maps of new features and functions. You can also use the land cover data as an input to a model to look at the impact of different processes that your model might capture and to understand the impact of land cover on those processes. We do have quite a growing number of land cover maps now. So this slide shows the full land cover map series. The first land cover map we've got is for 1990. We reproduced that a couple of years ago so that it's now consistent with the later land cover maps. Land cover map 2000 and 2007 are still in a slightly different spatial structure and have slightly different classes, so they're not quite as compatible as the rest of the data. But we do plan to change that in the future so that we will have a much more compatible time series and we will have much better land cover change mapping. A couple of years ago, we did also release a land cover change data set looking at 25 years of land cover change. And it's quite difficult doing land cover change in the UK. The UK landscape is very fragmented. We have very small patches of land sometimes, so it's quite a tricky place to look at land cover change. And to get a better land cover change signal in our land cover change data set, what we did was we used 6 simplified land cover classes. So it's a simpler set of land cover classes than the normal land cover data set. But it allows us to understand what the changes are that have occurred in the UK. And actually we know I think most of us know anecdotally what those changes are because we see them in the kind of areas that we live. But the data set shows the increase in woodland and the increase in urban, but also shows that that's been very much at the kind of had a kind of negative impact on the amount of arable and the amount of grassland across the GB and across the UK. And because we're producing spatial data, you can look at the trends of this spatially, so you can see which counties and which areas have got the biggest increase in woodland or the biggest decrease in that arable or grassland or whatever you're interested in. Now, I mentioned earlier that one of our kind of big aims of our kind of the project that underlies the land cover map was to reduce the barriers to access. And one of the things that we produced last year was a spatial explorer tool with some of our colleagues at CEH. So that even if you don't have any GIS skills, you can now access the land cover map data and you can view it. So the tool lets you view the data. You can also explore just an individual class if you want. So you can turn off all the classes you're not interested in and just leave the classes that you are interested in. But it also lets you plot some simple statistics as well. So you can plot a kind of pie chart for Great Britain or for county level as well. And this is important because we want people to have better access to the data so that it can be used more widely. You can also use the Spatial Explorer tool to create maps as well. And a second strand of work last year that was also in this area of reducing the kind of barriers to access was that we introduced a new data set for the first time in quite a few years. So we've now got an LCM statistics data set that we're going to publish every year. And that covers the land cover for different geographical units. We've got countries, counties, and English regions. The data sets are produced as text files, but also spatial data files. So if you just know how to use Excel, you can download the text files, you can open the data in Excel, and you can get the statistics out of there. And this will be a kind of core part of our land cover products going forward. And we've got two mystery maps on here built out of the county data. So I don't know whether anybody's been looking at those, but if you have, the first one is the map for freshwater, percentage freshwater across the UK at county level, and the second one was arable. So you can produce maps like that for all of the land cover classes that we've got in the land cover map. If you want to access the data, and hopefully after seeing the talk so far you do, you can access it through EDINA Digimap, and you can also access it through the CEH website. As I mentioned, we produce the land cover data in a range of data formats. So we've got the landing page here from the EIDC, which is the CEH website that produces the data, but the data is also mirrored on EDINA. And the data sets basically are a mix of raster data sets, also vector data, and a range of 1K percentage cover data sets. Now, I know looking at the slide here, it's not very easy to understand which data set you might want. So I'm just going to show you an example for London. So this is an aerial photograph for the centre of London. This is the 10-metre data. So the 10-metre data is the most spatially detailed. So if you're interested in a small site, this is probably the data set that you would want to use. But you can use the 10-metre data for all of the UK if you want as well. But it's particularly useful probably for kind of smaller areas. We also have a vector data set. This is very good if you've got other data that is also in a vector format. It's a little bit more difficult for most people to use. So we also have a rasterized version of the vector data at 25 meters. So this might be the data set that a lot of people would use for all of GB because it's a little bit smaller than the 10-meter and it's easier to use than the vector data, but it still gives you a very high level of spatial detail. But if you're combining the data, the land cover data, with other data sets that may be at 1 kilometre, like a lot of hydrological or climate data sets are, then we've also got a 1 kilometre set of data as well. So these give the percentage of each land cover class for 1K square, or they give the dominant land cover for 1K square. And generally you'd use these if you had other data sets that were also at 1 kilometre or 5 kilometre resolution, so where you've got other coarse data sets. So just a kind of quick comment about what we're doing in 2026. We'll be releasing LCM 2025 in May or June time this year. We'll be updating the land cover map stats. we think with additional geographies, we'd like to include catchments in there. We're thinking also about whether we should include parishes as well as a kind of more detailed geographical unit. And there will also be probably a land cover application report just explaining some of the work that we've got going on in the background to kind of move us forward and to improve the quality of the mapping of some of the land cover classes. And just finally, if you're interested in further information, there's information on EDINA and the UKCEH Land Cover Map webpage. We also bundle documentation set when you download the data. We've got a couple of journal papers as well that outline the data set and some of the methods that go behind that. And there's also a report that we did for the Office for Environmental Protection on recent land cover change that also has some information on land cover change specifically that might be kind of useful for people if you're interested in kind of what you can do with land cover maps for land cover change. So I'm going to stop sharing now and pass over to Emily, who will talk about the Land Cover Plus data sets.
Yeah, I can do so. Let me just share it. Okay, this should be working. Someone yell at me if it's not, because I can't see anything else.
It looks great. Thanks.
Great. So yes, I'm Emily. I'm going to be talking about the Land Cover Plus data sets. These are a bit different to the data sets that Claire was talking about, but they are kind of derived from the land cover map, notably from the arable and horticulture class. So we get the land cover plus crops maps, and then from these we can derive the fertilizers, pesticides and hedgerows maps. So I'll be talking about these 4 different things here. So if we start with the crops maps, we now have data for 2025, so that brings us to 11 years of data, which is exciting. It's a good time series to have. The crop map is a vector polygon product, and this is produced annually since 2015. It was the first Great Britain-wide field-level crop map produced jointly by UKCEH and remote sensing applications consultants. It is built using Sentinel-1 backscatter and Sentinel-2 optical data, and we get just shy of 2 million fields classified each year, which you can see from the field parcels in the right-hand picture. And we get up to 16 different crop types classified and also verified per year. And I say up to because in the earlier years we had fewer crop types, and now due to technological and methodological developments we're able to classify more crop types. And that's not to say we're just pulling them out of thin air or anything and identifying fields that never existed before, but these are crop types that were derived from previous ones. So the old ones diverge into new types. So for instance, we've got winter oats that came out of winter wheat, and also we now have spring and winter field beans, and also peas, which were all used to be derived from the field beans category. So if you want to look at the time series and the changes that happen within it, then sometimes it's more appropriate to put the newer types back into what they used to be, to look at that consistency in the timeline. The classification methods happen not through just looking at one point in time, but at several points in time across the spring and summer growing season. Because as you are aware, I'm sure, fields look very different at different points of the year, depending on how they're growing. And this can be dependent on the colour, the texture, the tone of the images we're getting. So they all go into feeding the modelling techniques and then classifying the crops. As I said, we've got multiple years of data. This means there are many possibilities in which to use it, whether you want to look at a moment in time, so look at 1 year of data, or whether you want to look at a series of data. You can string together the ID codes for the same field parcel through the years to look at sequences. And And yeah, some of those fields split, but you can then follow the parent and the child identification codes and get those anyway. You can look at crop patterns in relation to other issues more broadly. So you can bring in regional data, weather, climate, topography, river patterns. You bring in economic data and biodiversity data as well. It really depends on what you're looking at. But in many sort of fields of research, agricultural data is actually quite relevant. So I had a look in the literature and I thought I'd pull out some examples where the crop map has been used. So on the left here, we've got some simulations of crop sequences based on sort of current patterns in crops and projecting this into the future. In the middle here, some research I did with colleagues looking at characterizing crop rotations and predicting the next crop in a rotation. And on the left, we've got some work on predicting grass pollen concentrations and spread. And it turns out that it was pretty accurate to life, which was quite exciting to see. On the left here, we've got some work looking at investigating effects of future agricultural intensity on insects. And this was looking at different groups of insects and different scenarios of agricultural land cover, land use, and how that varies between those, and also how it varied geographically as well. And then lastly, on the right here, some work done creating a family of process-based models simulating landscape use by various groups of species. You may have heard of the Pol4Pop model, although you might not have heard of it. But the 4POP models are a series of models that look at estimating populations of different groups of species based on what is sort of happening in the landscape. Moving on to our fertilizers maps. I'm hoping this GIF is showing all right for you. We have some new maps, and these maps are for individual years this time, covering 2015 to 2021. It's a raster product with 1 kilometer pixels, and each pixel shows total fertilizer application in kilograms. And yeah, we have this for nitrogen, phosphorus, and potassium across England, and that's because the data used to model this came from just England, and we aren't able to extrapolate beyond the data we've got. So we have data for application and also for uncertainty. These maps were produced using the British Survey of Fertiliser practice, so using anonymised data for the years 2015 to 2021. These then went into a spatial interpolation model, and crop area was also brought in, and then these 1 kilometre applications were created. We still have the older version of the fertilizers map. It's not been sort of overwritten or anything. This is because it's showing different things. So the main differences are that it's looking at a previous set of years, so 2010 to 2015, but that it's also looking at the average annual fertilizer application within these years. So it's very much a snapshot of what was happening during those 6 years rather than what is happening in individual years. So it's not sort of directly comparable to the new maps. You probably wouldn't want to look at change in that same way, but it is still out there as a separate product. Then we've got our pesticides maps, which are a bit similar to the older fertilizer maps. So it's a raster product, again, 1 kilometre grid cell, showing average annual pesticide application for over 160 active ingredients. Again, this is in total kilograms per kilometre squared per year. And we did have data across England, Wales, and also Scotland, so it's a bit different to the fertilisers maps. Again, it's this snapshot of what's happening between 2012 and 2017. And again, we have application and uncertainty maps. These maps were created using county level data from FERA's pesticide usage survey and also data from Scottish Government. The pesticides are crop and location specific, so this was very much taken into account during modelling, and crop map data was brought in for 2015 to 2017 in the model, but also to fill in gaps spatially where there weren't data from the pesticide usage survey. Oh, before I go on to that, it's worth saying, I think Claire mentioned about the 1 kilometre grid cell thing and how that's useful. While it is important to know what's happening at fine scale with pesticides and fertilizers, these data aren't for looking at fine scale patterns because of the interpolation. So it is much more relevant to use it if you're looking at regional patterns and national patterns, but not if you're trying to figure out sort of which farms in the landscape are doing things differently. It's not appropriate for that. But again, big scale patterns, yes. In terms of how these maps have been used in research, I've been having a look, and they fall mainly under the umbrellas of predicting environmental fate and impacts in planning and environmental protection, and also water quality management. So some of these are focusing more on this of what's happening in the landscape side of things. So we've got estimating pesticide loads in river catchment areas. We've got modelling change in land management intensity and characterising agricultural landscapes. There are then some others which are looking at sort of what the effects of this. So things like estimating agrochemical exposure risk in honeybees, modelling impacts on crop pollinators and pollination, and also identifying broad areas of potentially lower sustainability. And then finally, what are we going to do about that? We have this research on developing a novel strategy to improve water quality management. Our final set of data are the hedgerows maps, or is the hedgerows map. I'm just showing you sort of still images here, but there's a link here to a visualization if you want to see it all moving around. It's quite nice. This is a vector linear product, and this is again another snapshot looking at hedgerows in England between 2016 and 2021. We've got almost 400,000 kilometres of hedgerows mapped in England, so it's a pretty large data set, I have to say. It pulls apart sort of different aspects of hedgerows, so things like different height classes. So we've got hedgerows that are like 0.5 metre all the way to over 6 metres, and this will encapsulate not just sort of hedgerows that are all well established, but also young hedgerows which have been recently planted, all the way to trees that have grown up in the hedgerows as well. Hedgerows are mapped when they're over 2 metres in length, and then we've also got information on hedgerow structure, so whether it's a single hedgerow, whether it's a double one, that kind of thing. This data set was produced using Environment Agency LiDAR data, and it spatially integrates with the land cover map vector and the land cover plus crops maps. So the linear hedgerows snap to the polygons exactly of the land cover map and the crop map. The hedgerows dataset is also compatible with countryside survey height classes, and then we also found 80 to 90% accuracy of hedgerow lengths when compared to field verification. So I thought I'd just show you what it looks like using this image here. So this is a sort of typical agricultural landscape. On the right, there's this lane that has hedgerows either side of it. We have like this sort of probably building at the bottom, and then another hedgerow off to the top left, which is a little bit less uniform, a bit more patchy. So if we bring in our crop map, so we can see the field boundaries it's got here, and that our hedgerows map lines up very nicely with it. We can see where this lane was. We've got a nice uniform hedgerow height classes that's probably managed quite evenly. And then this top left one here, which is sort of more heterogeneous, perhaps is managed a little bit differently or is a bit older since, a bit longer since its last trim. Yeah, so it can identify these different patterns, which is quite cool. And then the width classes, so this lane, it had the double hedgerow, which you can see has come up and been recognised, and then everything else is a single hedge. So because this is quite a young data set, I think it was produced a year and a bit ago, maybe a year and a half. I couldn't find any published data, published research on it, but I know there's definitely a few projects there on the go. So hopefully next year there'll be something to share about it. The hedgerows map is a benchmark data set. So as I said, it was this snapshot of a few years. The hope is that in future years we'll come back, we'll model a new hedgerows map, and then from that you could look back to this one and have a look at the changes in the hedgerows from one set of years to the other set of years, and then also sort of use research based off that as well. The hedgerows map could be further developed or used in different ways in relation to sort of policy and sort of things that are happening at the moment, where the funding is basically. So things like carbon storage is quite useful to know, and you could use the hedgerows map to do some estimation work there. Hedgerow height can infer hedgerow management. So again, it could be used in that way. And then we know that hedgerows are important habitat corridors in the landscape. So if you're looking at sort of biodiversity movement or connectivity of different patches, the hedgerows map could probably be quite useful in your research. And then this is just a link to a podcast that CEH made on the hedgerows map, sort of more into how it was made and why. Looking ahead into the next year, we're expecting to have a new version of the pesticides map. This won't be quite the same as the new fertilizers map. So it's not going to be annual maps, but it's going to be 3 different time slices. And these will capture the changes between these sets of years, most notably the sort of ban in neonicotinoids in 2015, which is fully encapsulated in the old version, but this version it will split up and you should be able to see those changes more clearly. And this will follow the same data and methodology where possible as the old maps. And then we anticipate our next crop map will be out next winter. In terms of licensing, I'm not the person to ask. So if you have questions, please direct them to the Digimap team or email our licensing team. But as far as I know, the Land Cover Plus series are free for research purposes through Digimap, which is the same as the Land Cover Map vector. So yes, thank you very much for listening.